Hello, everybody. Welcome to the Generative Design Community Meetup. My name is Mike Fiedler, and with me is Paulo Vanderberg and a variety of panelists for this special AU presentation of our meetup. If you want to page down to our next slide here. Before we get into our presentation, we're going to start with a couple slides from Adam Mentor, who is here with us, a community program manager, to speak about the Autodesk Group Network. So feel free to go ahead, Adam.
All right, hey, thanks. Just wanted to take a few beats at the beginning of this conversation to let you all know about a program that was launched last year called the Autodesk Group Network, whose goal is really to extend the types of community conversations that are happening in this type of a meetup forum. So I think we're going to start with a poll, and I will launch that right now. If you could just quickly indicate whether you're interested in finding other meetups or user groups to participate in, whether that be virtual or in person in your local area. Give a couple more beats for folks to answer that. Okay, so it looks like 55% of you said yes. And really that's the intent of this program that I'm about to share with you, is to enable you all to find and get involved and potentially lead groups like that. So the group network is a global network of user groups, developer groups, and online groups. And it does include online groups, which has been clutch during the pandemic here. And really the goal is to help each other learn, build relationships, share knowledge. And the vision of the group network is to connect people in community to share knowledge and collaborate across firms and industries to improve the use of design technology and make a better world. You can go to the next couple slides there, Apollo. And how we do that, you can go to the next slide, is really by working to support group leaders and giving them the tools and resources and connections to manage user groups, grow their communities, connect and collaborate with other leaders. And often this is helping folks who are leading and in these communities reach their personal and professional goals and adopt new and better ways of working. An important sort of philosophy that we have with the program is that Autodesk is trying to support these groups without trying to centrally control or own or dominate the conversation. So if you're interested in finding a group, I'm going to put the link to the program homepage that has a group finder there in the chat after I'm done talking. So take a look around, see if anything is of interest to you. You can go right to the websites and platforms of those groups. You can go to the next slide, Apollo. It's the last slide, and I think we're going to just end with one more quick little poll, which is, have you ever thought about leading your own meetup or online group community? Of course. Leading is not a prerequisite. Just being part of it is an act of participation and leadership as well. But part of what the group network is seeking to do is to support folks who want to lead communities. So we've been building resources and best practice guides and actually ways to connect with other leaders to support you in that journey if it's something that you would like to do. So I'll close the poll now. And it looks like 22% of you said you might be interested in leading a community. So I invite you to check out the Autodesk Group Network, and I'm going to post another link there called the Community Dojo, which is actually an open source project that the Group Network has started to basically just build resources and templates and tools for folks that want to build community, and maybe those communities can turn into industry movements and etc. So that's what I had to share with you. You can also email us at groupnetwork@autodesk.com if you have any other questions or thoughts. All right, I will turn it back over to Paulo.
All right, thank you, Adam. Appreciate the the presentation there. So we're going to go ahead and move into the generative design portion of our presentation. Before we do so, of course, we need the standard safe harbor statement. This one's going to be a little bit different than what Apollo and I have been doing for more than a year now, obviously, because we are in AU week. We're going to do a little bit of a look back at some of the things that have come up in generative design over the last year. We're going to talk about some of the classes that are happening this week at AU around generative design, highlight a few of those for you so you know where to look. And then we're going to talk about some of the upcoming developments with the software. So of course, the safe harbor statement here, in general, you should not make purchases of software if you're thinking about getting into generative design based on things that are not yet in the software, of course. So I guess that's about all I have to say about the safe harbor statement. You can go ahead to the next slide. So for all the time that Apollo and I have been doing these presentations, I don't think that we have ever necessarily had our pictures up there and background on us, maybe in one of our first presentations, but it's kind of an AU thing. So there is a photo of Apollo. He'll be running the slides today, helping to answer some of the questions when we get into the Q&A session for sure. One of the designated support specialists here, a mechanical engineer, been working with CFD for quite a while now and also supports NetFab and generative. I myself, also a designated support specialist, mechanical engineer, been focused on FEA for the last 21 years and also support for generative design. So a little bit about us. And then super special AU, I'm happy to have the additional panelists here with us today include Mike Smell, Senior Product Manager for Fusion 360. We have Brian Frank, who's a Senior Product Line Manager, and Dan Miles, Senior Manager, Design and Manufacturing Strategy. So they are here with us today, and when we get to the question and answer session, they're going to be here to listen to your questions, help us answer some of those questions that come up. Super awesome. And then I'm sure they would love to hear some of your feedback on the program as well. So we do have content to present. I'm going to try and get through that as efficiently as I can so that we can get to the good part and speak with these guys. So our agenda, again, a quick 30,000 foot generative design workflow overview. We're going to do a year in review of 2020. We're going to talk about the generative design classes at AU, do the look ahead, and then the awesome part, get to our open discussion. So super excited about that. So let's first of all talk about the workflow overview. Again, we're going to do this really high level. In Apollo and my regular presentation, when we do this webinar basis, we talk about what generative design is, and then we go through a walkthrough start to finish on a project in generative design to show you what that workflow is. And then we always like to have a Q&A session. So there's lots of classes. Again, we're going to highlight some of them happening this week that will dive in and really what are all the steps. We're not going to get too deep on it in our presentation today. What I will do for those of you who might have dropped into this presentation and be wondering, what is generative really about? Again, I'm going to point you to some other deep dive classes, but at the high level, you're going to start with some sort of CAD model, right? And we're going to take a look at, say, for instance, the control arm on the suspension. And what you're going to need to do is project some geometries. And the reason that you are projecting geometries, if we move over to the define step, you'll see we took those CAD parts, and in generative design, you define some of those parts as preserve regions. So those would be the areas that you see there. And what those preserve regions mean is when generative design does its thing, you want those bodies to exist in the solution. And then you can see that some of those parts or bodies are red, and those would be your obstacles. So you define for generative design avoidance regions, that is where not to create geometry. And that could be within holes because you're going to insert a pin or a bolt later. And like the rectangular region there, it could be something that you need to avoid collision, something else in the final assembly because of a range of movement or something like that. Other things to define include constraints. Is it free to translate? You're going to define loads, so forces, pressures, moments. You'll define materials. You will define manufacturing methods. All that goes into generative design. and then it generates outcomes like you see there in the fourth step. That is highlighting a single outcome, but of course, generative design is going to generate many outcomes. It's one of the strengths of generative design, and you can review those outcomes in different ways. So we're showing there a scatter plot of all these different outcomes, and then you can isolate them based on their mass or their displacement, the stress, things like that. And there are different ways to explore those outcomes as well beyond the scatter. You can look at them in table form, you can look at them in thumbnail form. So again, just a super high level generative design workflow. And again, I'll point you to some other classes which will go in much deeper. I'm going to take a moment to talk about some of the different manufacturing methods. Again, another strength of Autodesk Fusion 360 Generative Design are the variety of manufacturing methods that we have. There's additive manufacturing, there's die cast, 3 and 5 axis milling, 2.5 axis milling, and 2 axis cutting. So a lot of the times, I will say, it comes up in our Q&A session that people say that some of the outcomes look very elaborate, like you just saw it with that control arm. And that's true, right? Because it's flashy. It makes people take a second look and they say, how did we generate this outcome? I would say that you have a variety of manufacturing methods available to you. If you do something more like a 2-axis cutting and even some of the die cast output, you would see something maybe more traditional looking, and people might not even know that you utilize generative design to create that. So it is possible too, if you are on the fence at the moment and say some of these outcomes look just maybe a little bit wild for what we're ready to do right now. But certainly, yes, explore all the different manufacturing methods available to you. All right. So the next thing we're going to do is a year in a review. And I wanted to take a couple of minutes to talk about some of the things that have come out in generative design within the last year. Again, when Apollo and I do our typical presentation, we're focused on helping people understand what generative design is, and we're focused on a pretty straightforward start to finish process or workflow. So that way people can watch that presentation and say, okay, this is how I get started with design, but we're not necessarily always informing you about what some of the latest developments are. And so we're going to take a moment to look at a couple of them here. If you want to go down to the next slide here. So I just picked out a few of them. There were certainly more, and we'll mention that or talk more about that in just a moment. But to highlight just a couple of them again, starting in May, there was a material definition per manufacturing process. And the reason that this was implemented was because sometimes you might choose a material but it is specific to the manufacturing process, right? You might have a material or a couple materials that you want for an additive process, but it doesn't necessarily make sense for either the milling process or maybe a cast process. So then you can define a different material for those different processes and get the outcomes for those different manufacturing methods, but also specific to those materials. So that really was a nice enhancement that came out back in May. Also in May was the improvements to the preview experience. So we've had the previewer there for a while, and it's maybe something that Apollo and I haven't really stressed the use of maybe as much as we should. But in your workflow, once you have the preserves and the obstacles defined, you have your loads and your constraints on those geometries. Maybe before you actually start the generative process, it would probably be wise to run the previewer just to take a look at how the design is going to evolve and make sure that you have everything set up appropriately. So it'd be a good opportunity for you to catch something. Maybe you go, oh, I see that it's generating material in a certain region where I need to have an obstacle, so you can stop and add in that obstacle. Or maybe your loading is not correct, so you can go back and change your load, either magnitude or maybe the direction was accidentally set wrong. So in May, automatic starts were added. So if you go back and you make some sort of change to it, the previewer will start over and take into consideration those modifications that you're giving to setup. Also, in addition to that was more control. So you have the ability to set this either to a coarse, medium, or a fine level of resolution, depending on what you want to see out of the previewer. So again, gives you a good idea about the outcome or the type of outcome that you might get from it once you actually kick off the solution. Moving over to June, I think also another good one was individual access extension. And this can be either monthly or annual. Call it design without limits. And basically the logic behind this was, some people mentioned we want to be looking at the cloud credits in our face all the time. How many credits do I have? How many credits is this going to cost me? I just want to be able to run designs and get outcomes. So you can now either do a monthly subscription or an annual subscription, which gives you access to unlimited solves. So certainly something that, depending on how you plan to utilize it for, might be something of interest to you. Moving into the September timeframe, and this is something that was always in the back of my head, within the last couple of months to incorporate into our standard presentation. Just haven't gotten around to it, but the more that I explore it, the more interested I am in it, and the more I think it's really something that we should explore. I'll talk more about it later here with one of the courses happening this week. But the experimental solver allows a number of different things, and if you don't have it turned on, when you're in Autodesk 360, you can go up to preferences, and from the preferences you can click the box there for experimental generative solvers and features. And some of the things that includes are displacement controls. So you can say, I don't want to see outcomes if the displacement exceeds a certain value. You can include modal control. So imagine that you're a generative design and it's something that's going to attach to a pump or a compressor, right? You don't want the natural frequency of the outcome to match the operating frequency of that pump or compressor and have the thing shake around like crazy. So you can include modal controls. There's also buckling limits that you can impose, right? So in some of the outcomes, you might have rather long, slender portions of your geometry, and these are things where we might begin to get worried about or consider whether to experience buckling. So you can include some safety factors in regards to buckling. Also included would be outcome geometry. So this is another thing that comes up quite in our key sessions. People say, well, I'm looking at that result and maybe I expected that to be a little bit more symmetric in the outcome where I'm not seeing that left to right or on the geometry. So with the experimental solver, you can add in a plane so you can impose symmetry left to right on your geometry or maybe top to bottom so that you get a symmetric outcome. And in addition to that, once you take that outcome and if you export that and you're doing some post-processing, say with a T-spline geometry, you can also do symmetry there so that if you make a modification one half of the geometry, you will see that mirrored to the other side of the geometry as well. So makes the post-process. And then in October, one of the features I want to talk about is recommended outcomes. So one of the nice things there is that, with generative design, you can have, say, at the smallest end of the spectrum, you might have a half dozen outcomes, right? But you have 10, hundreds of outcomes, and it can be maybe a little bit difficult, or I don't want to say difficult, but time consuming to go through all those different outcomes and really say which one of these are ones that really drill down on and are going to be best for us. So we now recommend outcomes, filter to the top of the list, and you have control over that. You can say, you can give different weighting, like maybe the mass is very important. Maybe the cost is not so important to me, and based on how you set these controls, we can filter up the recommended outcomes. So again, here I just wanted to highlight a couple. We're highlighting 5 different things that happened in 2020, and this is really one of the strengths of Fusion and generative design. Being a cloud-based platform, we can release things frequently for you in some great functionality. In the lower right-hand corner, I just want to highlight and Brian do have a core generative design in Fusion 360, a year in review and a look ahead where they will outline these plus more in greater depth. So if you're really interested in all the different things that came out in 2020, make sure you take a look at that class. All right, if we move into the next slide here, one of the other things that happened in 2020 and is being announced this week at AU is the Generative Design Manufacturing Certified Expert certification. So if you've been part of the Autodesk products for a while, you might be aware that we have certifications already for AutoCAD and for the Inventor product, Mold Flow products. And there are different levels of certification. There's associate, there's professional, and there are expert certifications. So if having that certification is something that is important to you and you really are going to get into generative design and say, this is part of my professional career, now you have expert level certification. Myself and some of the other panelists here today were involved in that certification, reviewing some of those questions and saying, look, some of these are too easy. It's just a simple memory exercise. And then other times on the flip side of that, sometimes maybe they're a little bit too difficult. The wording was maybe just a little bit too tricky, or the image maybe didn't show what was trying to be conveyed in the question. So we also participated in reviewing those questions. If this is something that is interest to you, please visit autodesk.com/certification. There are learning paths that you can take to get to the point where you're ready to be certified. If you start a course by December 31st, 2020, you can watch for your free certification offer, and then you can complete that certification by March 31st, 2020. So certainly keep that in mind if this is something that you want to consider, again, professionally. All right, we're going to move into the next section here, which is highlighting the courses this week in regards to generative design at AU. So let's take a look at some facts and numbers. There are more than 750 on-demand and live classes at AU this week, completely awesome. There are beyond 350 live classes, QAs, roundtables, panels, meetups like this one that are happening this week. And if you do some filtering, you say, hey, I'm really interested in generative, you're going to find somewhere around 94 different classes on generative design, and we're going to kind of whittle that for you. One of the things that we want to do is say, you know, what might be of interest? Where do you want to focus? So we've hand selected 14 events that we're going to drill down on now. So a couple of the ones that we selected, and myself and Apollo and Mike Smell, we got together and we said, hey, you know, we want to give a list here of ones that you might specifically be interested in as a learner of generative design. And we did that based on, you know, some of them are colleagues that we know, other ones are descriptions of classes that we thought sounded really intriguing. So to highlight a couple of them, first one here is the Live Factory Experience, Design and Make a Laptop Stand. This is being hosted by Peter Champneys. He's a technical consultant at Autodesk. So live from Birmingham, UK, our technology center there, he's going to go through the design and making of a custom laptop stand using generative design parameters, 3D printing, CNC machining, all inside of Fusion 360. So there's one up in the next hour. There's been quite a few of them. I don't know if there are slots still open for the next session, but certainly something that could be of interest. The next one there is Bridging the Gap in Generative Design Workflows. And the reason that we hand selected this one, it is being led by one of the Autodesk quality assurance folks and also one of our software engineers involved with generative design. So we think it's interesting anytime you get to hear from this end of the business. You know, frequently you hear from specialists like myself and Apollo and some of the leaders of generative design, but to hear from the guys that are really, you know, behind the scenes doing the work. And what this one is about is, you know, they saw that the production parts aren't necessarily very similar to what's coming out of generative design. People are doing a lot of post-processing in order to take that from the generative outcome to a production part. And so what this course is about is how can you maybe change the settings or inputs to generative design so that what you get out of generative design is more close to what you're able to produce, so that you have to do less work on the back end. So that might be something of interest. And then the next one we selected there, 30 tips and tricks. Who doesn't like to hear a lot of tips and tricks within a short amount of time? So we picked that one. I went through the slide deck on that one. Certainly a good refresher even to myself, some things that we should take advantage of in generative design to learn and utilize it effectively. Okay, so a few more. Generative Design Masterclass is coming up this afternoon at 3 p.m. Eastern Time. This is hosted by Matt LeMay, who in the professional world before coming to Autodesk was involved with additive manufacturing, and also our James Neville, who is one of our principal consultants and a very heavy user of generative design. They're going to discuss some pro tips with you and advanced skills for generative design workflows. I'm super excited about that class, again, coming up this afternoon. And then we have Inventor, Automated Inventor by Engineering with Generative Design by Alessandro Gasso, one of our generative design adoption specialists. Many of you might be familiar if you've been attending these webinars on a monthly basis for a while now. Alessandro and Matt used to do the every other month series. So this one will focus on the interop with Inventor. So if you are an Inventor user and also a user of generative design, that is something that might be of interest to you. Certainly early in the morning for those of us here based in the US, but you can catch it on demand for sure. The other one here, Generative Design in Fusion 360, a year in review and a look ahead. I mentioned that a little bit earlier. That is hosted by Mike Smell on this call and Brian Frank. And they're going to go into greater detail and more aspects of what happened in 2020 with generative design, some of the great features that came into the product, and they're also going to give a look ahead. So certainly catch that one. It is on demand, so you can play it anytime it's available for you. All right. And two more that the panel selected here. This first one here, workflow assessment for generative design in Fusion 360. What I will say about this, I watched this one on demand, and I have recommended it to people since watching it. It certainly was more thought-provoking than maybe I had expected going into it, and really presented more than I had thought was going to be presented in this. So what this one is all about, I think we're all familiar coming from CAD backgrounds or having some experience with CAD. We're familiar with how CAD packages have been ranked in the past, right? How they stack up against each other. One might be better for parametric modeling. One might be better in terms of surface modeling, right? And we can use that information to see whether a particular CAD package will fit our needs. Here we're doing the same thing. Joe is doing the same thing, but with generative design. How do we rank generative design programs against each other, against the industry standard? And how does Fusion 360 stack up against the industry standards? I thought it was a super interesting presentation on the criteria that is utilized to rank generative design. And then he goes into detail. How does Autodesk Fusion 360 stack up in each one of these 11 different criteria? There's technically 14, 11 that he says are for the masses to really be worried about. And he goes into some detail about that in his presentation. So I would certainly recommend that one. Definitely interesting. And then we have the when and why of generative design in Fusion 360, again hosted by Mike Smell, this time with product technical specialist Ryan Abel. And they're going to answer questions like, what types of problems is generative design good for? How do I get started? How do I get access? How much is it going to cost me? So these are a lot of common questions that people have when they're getting started with generative design. Certainly, if you are getting started with it, something that we would recommend taking a quick look at that presentation as well. All right, and then I kind of went rogue. Those were the ones that we came up with as a panel, or some of the ones we thought of as a panel. And then I said I'm going to add more to it. So I actually went through that whole list of classes that are generative design. And what I tried to do here was pick out ones that were purely focused on generative design or primarily focused on generative design. So you as a user of the program are looking to get into the program, what classes are going to really focus on generative design. So somebody have a Fusion class, right? Fusion 360 does drawing, it does modeling, it does simulation, it does rendering, and then they might say, oh yeah, and we're going to touch on generative design. I really wanted the classes that were heavy on generative design. So I went through and I tried to pick out some of those. So the first one there, experimental solvers. Oh, love this one. I went through the slide deck on this one. Again, several of Autodesk software engineers, what they did was they really drilled down on that experimental solver that I mentioned before. And they actually go through, what do these different options do? So let's take a look at the displacement control. Let's take a look at the modal control. Let's take a look at buckling. And they show you side-by-side results, what happens without that control on, and how does having that control on influence the outcome. So I would highly recommend this one as well for you to take a look at. If you don't have time to watch the whole class, at least you can access the slide and go through the slides, just like all the other ones here. And then there's generative design, getting the results. This one by Imagine It instructor Robert Savage. So he has done prior AU presentations. He's done one on preparing a model for generative design. He's done one on the bulk of the setup inside of generative design. What do you need to do to get the model ready? And then this year he is focusing on the results. So that is something that might also be of interest to you. The third one here, creating a drone chassis in generative design. I selected this one again because of the criteria of it focuses heavily on generative design. He also mentions there it's a good class whether you're a beginner or seasoned veteran with generative design. All right, if we want to page down to the next slide, a couple more here for you, the last three that I'm going to highlight. Generative design and additive manufacturing for work and play, led by Tim Van Ast and Tony Mazzillo in Autodesk Consulting. And the reason I selected this one is because they mention 3D printing. So a lot of the other classes here, we didn't focus on any particular manufacturing method, but it occurs to me that you might be getting into generative design and you might be limited to 3D printing as your manufacturing method. So they're going to dive into generative design with 3D printing, so that might be good for you there. The second one there, generative design helping students improve their career prospects. Led by the professor at South China University of Technology. This one dives into how they are incorporating generative design into their courses. So I paged through the slide deck on this one. I think it's quite interesting. If you are in an educational space, this is one that you might want to check out as well. All right, and then the last one here, getting up to speed with automotive manufacturing. This is one that violates my rule, right? I said I was going to include classes that were heavy into generative design, but without this one, I had a list of 13, and myself, like maybe some of you, we have an issue with the number 13, so I can't leave you with just 13 classes. So I incorporated this one. Robert Walker is going to cover topics of automotive manufacturing, mold simulation and CAM, factory planning, automated manufacturing, but then he also dives into emerging design like generative design. Automotive manufacturing and how generative design fits into it is something that is interesting to you, this is also one that you might want to take a look at. Okay. So the next thing we're going to do is a look ahead to what's coming in the future with Autodesk Fusion 360 Generative Design. So at this point, I'm going to welcome Mike and/or Brian. You guys can tell us about what we might expect from the software in the future here.
Cool, thanks for that, Mike. So as Mike said, my name is Mike Smell, Senior Product Manager on Fusion 360 Generative Design. Brian's joining me here as well. We're teammates and we kind of split split our time in the way that we work on the different things inside of the generative design experience. Myself focused more on kind of the user experience and how we get the models through the entire Fusion pipeline and downstream. And Brian does a lot of work setting up the back end for success. So working with our solver teams, working with all the engineers that Mike had picked out some classes on where they're really giving you kind of a behind the scenes look. So we'll talk through the next couple slides here in that context. So I will start with the first project that we're working on. And this is a longer range project that's broken up into a couple phases, and you'll see these things happen, some in the very near term and some in a little bit longer term, but it's really around getting to be able to work in the assembly context that you're familiar with. I'm sure for those of you who have looked at generative design so far, have a basic understanding that we're applying the loads and constraints directly to the part that we're doing the design exploration on. In some scenarios, that's not really difficult to do. We understand where the boundary conditions go. We understand how the loads are applied quite easily, and we can move forward from the process. When you get into some more sophisticated setups like you see here, it's not always obvious to understand, well, when this thing's in a system moving around, like I know the force applied out on the end of the hub, but how does that force get put into this steering knuckle that I'm trying to design? What are the boundary conditions where I bolted into the system? Are those, how does that all best represent what's actually happening in the system so that I'm not optimizing or designing the part to the wrong requirements? So again, we will take an approach to try to make this easier for you to work in the context that We'll start with things like remote forces and remote constraints, which are really well understood concepts in structural mechanics, and for those of you who are familiar with doing basic simulation and validating your designs. And then longer term, we will start to take a look at how do we allow the user to design or to set up the model in even a greater assembly context, just like you would doing a traditional simulation model where the loads are transferred through the entire system. Mike, if you want to go on to the next one. The other area that we have a big focus on, as Mike talked about, is around manufacturing. And one of the projects that Brian and I kind of have been tag teaming over the past couple months with our development teams is around additive manufacturing. So we've had an additive manufacturing constraint in the product since its inception. And it's been, it was our first step into, creating designs automatically for additive manufacturing. And what we heard from a number of our users is that, in a lot of scenarios, it just didn't give solutions that met their expectations. And part of the reason for that was it was trying a little bit too hard to make fully self-supporting designs, sometimes at the expense of creating shapes that were not really usable at all. So what we did, Brian and I went back to the drawing board with the feedback that we had got from a number of our users and talked to our engineering teams about how can we improve the shape quality, how can we improve the way that we address overhang angles, how can we improve the way that we handle minimum feature size, because those are the things that we were hearing were not quite meeting user expectations. And one of the things that we arrived at is that, one, we could improve our algorithms on all of those areas, but also, we relaxed our requirement a little bit about always trying to create a fully self-supporting design, to a detriment. And what we've made some really good progress and are hoping to bring this to market pretty soon. But what you can see here in both of these examples, kind of in the left half of each of the quadrant or the sections here, you see our current production solutions for both the model on the left and then the GE bracket that I think most everyone is probably familiar with at this point. Really leave a lot to be desired from a aesthetic point of view, from a manufacturability point of view. And on the right side of each of that, you see that as we move towards our in-development solutions, we get much more aesthetically pleasing parts. We get parts that, while not fully self-supporting, are much better quality for having consistent lines for support, and do a much better job of maintaining overhang angle and minimum thickness requirements. Brian, anything else you want to add on the additive stuff?
I would only add that, you know, this is the first step in some that will release with some additional enhancements continuing to come forward, right? We've talked to a lot of you about what things are important as you're trying to leverage additive manufacturing and trying to do additive manufacturing at scale. So we had a first set of requirements, which was, in some situations, the existing manufacturing constraints weren't working well. Can we do something to make them more robust? And I think we've started to take those steps. And then we've got a number of other things that we've heard from you about, you know, for instance, using orientation analysis, doing a bunch of things with different processes. So there's a whole host of improvements that will continue to roll out through the year. And we're just really excited to continue to evolve the solution. And that's one of the things I think we should always remind ourselves is, you know, even if you use something a couple months ago, there's a chance that it's improved and it's changed, because we're, as Michael said earlier, we're constantly releasing updates, new enhancements, new features, revisions, more robustness. So we just encourage everybody to kind of keep watching what we're doing, because it's a fast pace of development, and we're often bringing new capabilities into these solutions that you can take advantage of.
And then I'm going to turn this one over to Brian. He's been knee deep in this project for quite a while now. So Brian, take it away.
Yeah, thanks, Mike. So one of the things that we've heard from a lot of you is, hey, being able to use generative design for structural applications is great, but what about other physics? And so one of the things that we've been working on for quite a while, and we're getting closer to being able to give access to you guys to try, is being able to do generative fluids. So generative fluids, the way we define this is having the system help you to determine the most efficient flow path given a number of criteria. So we're focusing right now on optimizing for pressure drop, so minimizing the amount of pressure drop that happens when you take fluid from one location to another. We're really excited about this one. We think that there's going to be a lot of applications for this. There's a lot of fluid transport that goes on in flow control and all of your projects, and we're really excited about being able to have a generative design system help you design these flow paths. And the interesting thing about this is we're building on top of all the existing goodness that we have in generative design. So you'll be able to get this flow path as an editable BREP. You'll be able to use this flow path in downstream operations, whether you want to use it for like as a cutting tool in another solid, or you want to use it as an obstacle and then in a structural design, so that you could figure out how to encapsulate the flow, and if that flow device or flow path is actually doing some structural work as well. We think that there's going to be a lot of opportunity where you can start to combine fluids and structural. Ultimately, we're trying to get to that multi-physics solution. So we're really excited about this. If anybody's on the call that has an interest in this, I'd encourage you to reach out to us. There's contact information available in this, and if not, we can give it at the end, or throw a question in the chat. But we really think that this is going to be some high value technology for all of you that have to move fluid from one place to another.
All right, so that brings us to our open discussion point in the presentation. I know that when Apollo and I do this webinar on a regular basis, we usually have some great discussions. So I'm super excited to have Brian, Mike, and Dan here to help us and talk to you all. So thanks again, guys, for joining us, and feel free to throw your questions in, and we can discuss them here live. All right, so I see one coming in there. Will generative fluids be an add-on or included in the price? Is there any ETA? Anybody want to approach that one?
Maybe is Brian on mute? Okay, I'll take it since Brian's not here, and if he's got an input. So it's something we're actively working on. And as far as, you know, time to market, like we don't have a committed time yet, but this is something that we would like to have in customers' hands in the next calendar year. Whether that's first half, second half, around this time of AU, hard to say and commit to that now, but that is our aspiration, to have something in user hands in the calendar year of 2021. As far as the add-on and like the pricing, we don't have any of that worked out, but you know, our intent is to build this in the generative design experience that Mike and Apollo and we've all been talking about today. So you know, it will look and feel and behave and kind of follow all the paradigms that exist in the current solution. So I hope that helps.
Awesome. All right. While we're waiting for questions to come in, I do want to make one comment. I meant to say it a little bit earlier. If there's anybody on this presentation and you know, you had a presentation that I didn't highlight in the section that I picked, my apologies. Not telling anybody that any of the other presentations are not good. You know, I had the title and the description to go on. And I tried to just handpick out a few. So no offense if if that happened to be one of your presentations.
Yeah. So there's one comment in here saying that they're very interested in the generative fluids for electronics cooling airflow. You know, one comment kind of back to that. If you haven't seen, we do also have a class around our Fusion e-cooling, which is you know, has been a new feature recently within Fusion's capabilities. So if you haven't seen that, check it out, and you know, we'll kind of expand on that with the generative fluids as well.
All right. Let's see, what else?
Where can I find tutorials on generative design? So I put a comment earlier, as someone else asked similarly. So there are a number of different places where we have tutorials. So there are some within the help itself. There are some within Fusion as an in-context, in-product training. We also have a full course that Mike and I have curated on connectedlearning.autodesk.com under the mechanical engineering section. So any and all of those are great resources for being able to get up to speed on how to use generative and some of the details behind some of the assumptions being made.
Thank you.
Are the certification courses you highlighted similar to the Coursera paths? That one, I believe so. Dan, I don't know if you have any other information on how close they are to the Coursera paths that we had previously collaborated with.
I would say they're similar, but the Coursera one is probably more detailed than going through the self-paced ones.
Okay.
Thank you. Well, I like the next one down. It's a good one with Mike and Dan here. Maybe they can give us some insights.
Yeah. Will there be a future manufacturing method like frame where the part is composed by several standard elements like beams welded one to the other? I heard some time ago it was in development, but I'm not seeing anything on it now.
Yeah, so I can take a swing at this one. We absolutely have something that we've been working on. We did talk about it, I think, at AU 2019. I guess what I can say about it, kind of in as much transparency as you know we can share, is that you know we were going down a path and we had some concerns about our ability to be able to meet the needs of the requirements that we were hearing from customers, and we kind of went back to the drawing board. So there is still technology alive. There is still interest in being able to try to solve these types of problems, but we need some additional efforts in R&D to be able to solve these problems in a robust kind of way.
Yeah, it's an active area of research. So when we think it'll have the level of robustness like Mike said, we'll definitely bring it to market.
Yeah, thanks. So this one might start a decent discussion. It says, this might be a little vague, but could you discuss generative design from the perspective of process design, working on an algae reactor, raceway, paddle wheel, baffles? Are there any examples you could think of?
So I'll take a quick stab at that.
Yeah.
So I think the most interesting thing about generative design is, in order for you to be effective with generative design, you have to understand the problem that you're trying to solve. So not knowing all of the problems that are involved in an algae reactor, but assuming that people on the call probably do, it's really one of those things where you kind of think about it and look at, are there areas of this design where I need to make sure that I'm looking at a combination of how I want to be able to produce a part, how strong do I need it to be, how light do I need it to be? Am I having an area where maybe there's a lot of opportunity for failure, or is there really kind of a complex design space that I'm not sure how to solve the problem? Those are great opportunities for leveraging generative design. And that's in the product design itself. The other thing I think is important to keep in mind is your ability to leverage generative design for the production engineering that goes on. So we see a lot of customers very effectively use generative design to help aid in the production of the product that they've actually designed as well. So that's another thing to kind of think through is, if I have to create tooling or jigs and fixtures or things like that to help with the production of the parts or the assembly of something, these are all opportunities where you can leverage generative design, because you can get very efficient, effective designs in very quick time. And that's really what we're trying to do, is enhance your productivity. So this is one of those things where, not knowing the product itself that you're trying to design, you might want to reach out to somebody in our organization to help do some evaluation and see where things might fit. But it's really, if you understand the problem that you're trying to describe, generative design can often help you create a solution for that problem.
Yeah, and I would also add here, Brian, to the asker of this question, I think it's Drew. I'd take a look at the class that Mike Fiedler recommended, the what, when, or the when and why of generative design that I did with Ryan Abel. One of the things that we tried to do in that class was not only kind of give some high level examples of like how to think about incorporating generative design into different parts of the design process. As Brian mentioned, like it's not always using generative design on the thing that you sell, right, or the product that you make that you sell, but the things that you use to make the product that you sell. But there's also some interesting thoughts in there about trying to simplify generative design in really the way that you think about it. So as Brian said, a big part of what we're trying to do with generative design is improve product performance, but also improve efficiency in the design process. And what we tried to boil that down to, it may be a bit of an oversimplification, but we see this very commonly, that folks kind of get mired in the what generative design looks like on the surface and the complexity of what they see, right? It's these exotic models, but reality of like what Mike has on the screen here, like this is out of generative design. Like something this simple can come out of generative design just the same. So we really tried to bring the conversation down to like, it really is just a tool to enable better engineering. So when you think about like, I have to go do a bunch of engineering tasks and design tasks and simulation tasks around these different aspects of a design, more than likely, if they have structural performance requirements, there's going to be an opportunity to leverage generative design. So we tried to break that down. So I'd encourage you to take a look at that class.
Great, thanks, Mike. We have a couple other ones that are kind of interesting comments here. So there's a, we'll say a shameless plug from one of our users out there presenting their own class around this, which is really interesting. Generative design, fusion additive and subtractive, leveraging desktop 3D printing and stainless steel. So that might be an interesting one to check out as well. And then as a question for you and Brian, in the future, what are your thoughts about anisotropic materials? Since today we focus on isotropic materials and some additive processes create non-isotropic properties.
I'll take the first swing at it, and Brian might want to add. This is absolutely a limitation of the solution, so it's fair to point it out. The one thing that we do today, and you'll see, as Mike said, there's a lot of things that we did over the past year. We've worked with a few different material providers to put materials in the library, so both Arkema and HP. And in those scenarios, we work with them to arrive at like the assumption that we would make is that we would use the weak direction properties. This may be too much of an assumption for some. For others, this might be a valid assumption. So that's like the first thing of like, how do we handle this today is we typically recommend to use the weak direction properties. As far as getting to support for anisotropic, part of the experimental solver preview, part of what's kind of lying in the guts of that is solver technology that will enable us to get to supporting non-isotropic properties. Obviously, there's still a lot to be done as far as like a user experience around that, as well as a library around that. But we are setting ourselves up for a foundation to be able to do this. But as far as like timing or when that might come to market, I don't think we can comment on that. Brian, anything else to add on this topic?
I mean, just an agreement that we're aware of it. We've heard it from folks. We're making moves to allow us to do those things, but the more information we can get about people and how they want to use the anisotropic nature of materials in their designs, the better, because we'll continue to consume that feedback as we make a solution for it. So I would encourage you to keep giving us that feedback.
Great. Kind of coming down to the last couple minutes here. Do you think generative design could be used to find the best place to put a lightning hole in a trailer main beam?
Yeah, I would say kind of this is right in the sweet spot of what it's trying to do.
Okay.
Now you may want to think about what does that mean, right? How much flexibility do you want to give the solver, right? Is it to completely reshape the beam? Is it to just look at the web itself? So how you develop your design space to solve that problem, will depend on what you get out of it. But at the very, very high level, putting in all your requirements for manufacturing, performance, and the basic foundations of the design space and letting it arrive at the lightest design is absolutely something that it's well suited for.
Okay, all right. And this one might need a little bit more of a clarification. It says last time I used generative design, it was for a 2D part, and after it ran, it had to be post-processed in a 2D sketch to outline the cutouts it designed to make into a clean, usable part. Is this something that still needs to be done, or is generative cleaning that up for you now?
So we've done a lot of improvements on that that conversion technology that goes from what the generative design solver creates to what is delivered to Fusion in form of a usable geometry. So without knowing exactly what had to be done, I would encourage you to inspect and try it again, because we have made a number of improvements there, and my guess is things might be a good bit better than they were before. So without knowing more, I would just encourage you to go try it and see if we solved the problem. And if we didn't, let us know so that we're aware of it and we can go and continue to make strides in making it work for you.
All right, maybe this will be the last one here. Looking forward to when moving component envelopes can be easily created as obstacle geometry. I guess any commentary on that?
Yeah, so this is something that's actively in our backlog to go look at. And the good news is we have technology to do this. The Inventor team, I think back in 2019, released some functionality that was not for the purpose of generative design, but for this kind of concept of moving sweep. They have some technology, we've evaluated it, and there's still some work that we think needs to be done before we could bring it to market for generative design. So in our backlog, absolutely, we have project plans around it, and we have some technology. It's just a matter of getting it really tuned up for our use cases in generative and bringing it to market.
Yeah, and Mike highlighted earlier our plans to continue to support generative in the assembly context, and we think things like this, sweeps and obstacle generation from moving parts, the ability to inflate obstacles more easily, a lot of tools around making sure you can easily define that design space are going to be critical as we continue to make the design space more complicated. So this is definitely an area of high interest, and hopefully you can tell from Mike's answer that we've already started the investigation and are well on our way to being able to do something. So we agree. I'm looking forward to it as well.
Okay. Well, I want to be conscious of time in case, any of you are jumping to other live events within AU or trying to take advantage of time to watch any of the courses that we had presented today. Brian, Dan, Mike, thanks for attending today. Fiedler, you got any other comments you'd like to throw out there?
I do not. I hope everybody gets some good content from this year's AU. It's a pretty interesting way to deliver it, and I think there's an awesome set of data out there for people to take advantage of. So good opportunity.
Yeah, enjoy the rest of your Autodesk University, and we'll talk to you guys next month for our next monthly meetup.
Thanks, everybody.
Thanks everyone.